scientists began using more nuclear power to prevent global warming from accelerating, which created a huge nuclear waste problem. Although, scientists built a machine to convert nuclear waste into electricity, which could make it a problem of the past. First, what exactly is radioactive waste and what is causing these problems? Radioactive waste is any material that contains radioactive elements that have decayed or have been produced as a result of nuclear reactions. It can come from a variety of sources, including nuclear power plants, medical facilities, and research institutions. Nuclear power plants produce radioactive waste as a byproduct of generating electricity. Hospitals and research facilities use radioactive materials for diagnostic and therapeutic purposes, which can result in the generation of radioactive waste. Some industrial activities that involve the use of radioactive materials, such as mining and processing of uranium, can also produce radioactive waste. The management of this waste is important to protect public health and the environment. Proper disposal of chemical waste is necessary to prevent contamination of the air, soil, and water. In most countries like the United Arab Emirates, there are strict regulations and guidelines for the management and disposal of chemical waste. It can harm our health, environment, and our safety. Exposure to radioactive waste can cause cancer, genetic mutations, and other health problems, both in the short and long term. It can also contaminate soil, water, and air, causing harm to wildlife and ecosystems. Furthermore, it can be used in the production of nuclear weapons or dirty bombs, creating a security risk if it falls into the wrong hands. Radioactive waste is a complex problem that requires careful management and disposal. By implementing safe storage, recycling and reprocessing, and investing in alternative energy sources, we can help to minimize the risks associated with this type of waste. Nuclear waste must be stored in secure facilities, designed to prevent leaks, spills, or other accidents. The waste should also be monitored regularly to ensure it remains contained. Some types of radioactive waste can be recycled or reprocessed, reducing the amount that needs to be stored and lowering the overall risk. Reprocessing involves separating out the useful isotopes from the waste, which can then be used in other nuclear reactions. Reducing our reliance on nuclear power can also help to reduce the amount of radioactive waste produced. Investing in renewable energy sources like solar, wind, and hydroelectric power can help to mitigate the risks associated with nuclear energy. Safe storage facilities must be located in areas that are geologically stable, secure from natural disasters, and away from populated areas. Ideally, the facility should be located far from sources of water to prevent contamination. Recycling and reprocessing facilities are typically located close to nuclear power plants, research reactors, or other sources of radioactive waste. They require specialized technology and expertise, which may limit their availability in certain regions. Investments in renewable energy sources can be made anywhere, but the best locations are those with high potential for solar, wind, or hydroelectric power. Countries and regions with abundant natural resources in these areas are likely to benefit the most from investing in renewable energy sources. All the electricity we use comes from spinning a turbine. Most of the time in a power plant, what happens is that a liquid is heated into steam and used to spin the turbine. The most common way to do this is by burning fossil fuels nearby. However, you can also use liquid that the Earth has already heated up for you, which is geothermal, or you can split atoms apart inside uranium to make them hot, which is nuclear. However, less than 1% of uranium is breakable and can sustain a nuclear reaction. Uranium-235 refers to the number of neutrons in the atom. Uranium goes through a process called enrichment, which makes more of the uranium-235 out of the less useful uranium-238. By the time this process is complete, the fuel looks like small pellets that go into long metal rods. The nuclear reaction happens when a bunch of atoms are fired into the uranium-235, which splits it into smaller and unstable atoms and throws off a couple of neutrons in the process. These neutrons then hit more uranium, and each time these atoms split, a little mass turns into energy, which makes the rods extremely hot. This heat then heats the water that spins the turbine and generates electricity. After 4 to 6 years, enough of the special uranium has been broken down, and the reaction stops working efficiently. The fuel is then considered high-level nuclear waste, which is a mix of 238 and a little bit of leftover 235, along with a bunch of unstable atoms that give off ionizing radiation. In large doses, this ionizing radiation is dangerous and can affect our tissues and DNA in deadly ways. This nuclear waste stays for a long time, about 200,000 years. In summary, we take uranium out of the ground, use it once, and then store it forever. This is called the once-through-fuel cycle, which works, but it is not the best cycle. The key is to figure out how to filter the useful material from the real waste that isn't. First, the nuclear waste is cut into little pieces, which are then dissolved into a vat of molten salts. When electricity is run through the vat, it separates the uranium and other useful materials from the other nuclear waste and pushes it across the vat, creating deposits of the useful stuff on the other side. Then, new fuel rods are made out of those deposits and stuck back into the reactor. This process can be repeated multiple times, making electricity while also reducing how long the waste remains radioactive. From hundreds of thousands of years to hundreds of years, which is a much easier time frame to store something. This new nuclear fuel cycle would look like this: mine uranium, use it, filter out the useful stuff, and repeat until you can't anymore. Store the waste in manageable storage. This is called a closed fuel cycle.